Now we're getting into a little bit harder. So we have to find that LCD, which means I have to factor each term. So far I've had nothing to factor. This is a factor, that's a factor, but I have to factor that. It has a GCF, guess what, of 2x times 2x plus 3. 2x times 2x plus 3. So what is that LCD? Write down one of every kind of factor, the 2, the x, and the 2x plus 3. Raise them to the highest power. Well, it's only to the first power. Here, 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 here. That is your least common denominator. So I'm going to multiply this one by 2x times 2x plus 3, this one times 2x times 2x plus 3, and this one times 2x times 2x plus 3. Then we're going to reduce. The 2x's reduce out, divide out to 1. Those divide out, and here all of that divides with all of that. So let's be careful. What do I have left? I have a 7 and a 2x plus 3. Here I have a 2 times 2x, and here the only have left is a 21. So let's distribute. Let's collect like terms, 14x and 4x. This is not quadratic, I just solved for x. I'm going to subtract 21 from both sides, and what happens if I subtract 21? Yes, I get 0, so I divide by 18, and 0 divided by anything is 0. Now I have to check. So where am I checking? I'm checking in here, here, and those are the same. So let's check. If I put in 0 for x, what's 2 times 0? That's 0. That cannot happen. You cannot have 7 divided by 0. That is undefined. Alright, you can't do that. But let's say you checked this first and you went 2 times 0 plus 3. Well, that equals to 3, and that's okay. But this equal to 0, that's undefined. So we're going to just put a line through it and say no solution. Sometimes we use the null set as that symbol of no solution. But again, I need to see all of this work. I need to see that you know x equal to 0, but when you checked it, it didn't work. All right, number 6. Again, can you factor that? No. Can you factor that? No. But can you factor this? Yes. And guess what? It's x minus 1 times x plus 3. Convince yourself. So my least common denominator is x minus 1 times x plus 3. So again, I'm multiplying this one by the LCD. Then we reduce out, and all of that goes away. Let's be careful. I have x times x plus 3. Don't lose that minus, the 6, right? And the x minus 1. And here everything went away except for that numerator of 4. Watch those signs. Don't be so messy you can't read what you have left. Now we're going to distribute. Make sure that x gets distributed to both. Make sure the negative 6 gets distributed to both. Watch your signs. Collecting like terms. I see that it's quadratic because of that x squared, so I'm going to subtract my 4, and I'm going to factor. Let's see, minus 1 and minus 2, right? And then I'm going to set them equal to 0. And solve for x. I have 1 and I have 2. I need to check. So again, I'm going to erase all this so I can see what am I checking. Okay, so I'm checking it in here, and since those end up being the same, I'll check that last just in case. Alright, so if I put in 1 right here, If I have 1 minus 1, what is that? That's 0. Even though if I put 1 in here, 1 plus 3 is 4, that's okay. If I put it in here, I wouldn't get 0. But here I got 0, so I have to throw that one out. Now let's check 2. So I have to put in 2 here. So 2 minus 1, well, that's okay. If I put in here 2 plus 3, that's okay. And since this really factors as both of those, I know that's not 0. So 2 is the only answer. I need to see all this work, including that answer, and I know that when you put that line through it, you've checked it and it didn't work. Don't just look at the answer and say, oh, the answer is 2. Practice. Then our last thing we're going to talk about is what I call cross multiplication. If you have a fraction equals a fraction, one fraction equals another fraction, a shortcut, if you will, would be to actually cross multiply. Don't leave out your equal sign. Meaning, I can multiply 2 times 7, which is 14, equals x times 5. And then just divide by 5. Now why that works is because you're actually multiplying both sides by the LCD of 7x. It's just a quick way, but it only works if you have one fraction equals another fraction. So it would not have worked on the last few examples. Okay, so number 7, this example 7, I could cross multiply by multiplying those two together equals multiplying those two together. Yuck. So I need to multiply all that out. This is going to really test my skills from all semester. Multiplying this, collecting like terms, because it's quadratic, I'm going to move everything to one side of the equal sign so I can get it equal to 0. And hopefully these numbers get a little bit smaller. So I know all of that is 0. So this is 3x squared plus 9x plus 6. Okay, I got to factor that. Well, first of all, I see they're all divisible by 3, so I'm going to factor out a 3. Oops, 3 times 3 is 9. 3 times 2 is 6. And then keep factoring, so I have x plus 2 times x plus 1. If I set those both equal to 0, I would get x is equal to negative 2 and x is equal to negative 1. Now where do I have to check those? Here and here, just the denominator. Okay, so if I plug in negative 2 here, negative 2 minus 14, is that 0? No. If I plug in negative 2 here, 5 times negative 2 is negative 10 plus 2. Is that 0? No. So that's okay. Now let's check negative 1. So if I have negative 1 minus 14, is that 0? No. If I plug it in here, 5 times negative 1 plus 2, is that 0? No. So now I have two answers. So look at those last three examples. This one we had two answers. This example we only had one because that is called an extraneous solution, extra solution that didn't work in the original equation. And then number 5, we actually had no solution. That's why you've got to check those answers. So again, you find that LCD, multiply every term by the LCD to get rid of the fractions, solve the resulting equation, and check those answers. So we are not dividing by 0 because dividing by 0 is undefined.